Okay, in the last video we had a look at what was happening here with our distributor and our pickup sensor. So we saw from our pickup sensor that it's producing an AC waveform and sending that down here to our ignition control module. We see when it comes in here, it has to go through an AC to DC converter and then it's sent into the chip, and the chip then controls a signal to the base of the transistor which links the coil earth side to earth. Okay, so what we're going to do is, if we look at it here on this particular model, we have wires on this, but on this particular model it plugs directly in through these two pins here onto our inductive sensor. What we're going to do is stick this back together, and then we're going to probe the system again, because we should, if we're able to probe onto the actual module itself here, pick up the primary waveform through the module itself. Okay. Okay, so this is just going to plug directly back into our inductive sensor through the two pins here. And we'll connect it back up. Right, okay. We've three wires going to this connector which are going to connect up to our module here. So what we're going to have a look at is what's what here. So if we start with our wire on this side, our black wire here, we want to see what exactly is going on here, because one of them should be a power. So connect there and go to earth, and we're looking at our voltmeter, and let's see what we've got. Correct. Sorry. Go ahead. So there's our 11 volts there. So our black wire is our power wire to the module itself. We have a brown wire in the center. So if I know that's power, what I'm looking for now is an earth. So I'm going to connect in here, and we'll crank again. So I know my center wire, because I know black wire is power, brown wire then is earth, which leaves me with this last wire, this green wire here. So if I look around to the back of the coil here, on the earth side, I have a solid green wire here. Pull it out here and have a look. Now, it looks like that's going to be our third wire. So let's change our meter setting to continuity here, and let's just check and see what we've got. Connect up to this and around to our coil earth side, and that's our wire. Okay. So if we reconnect now, we should be able to probe from our oscilloscope and pick up our primary winding signal on the scope itself. Okay, let's get a scope up. Now remember, on our scope here, our voltage, induced voltage into the primary winding is going to be quite large. So we need to set our voltage scale up to a suitable level on it here. So if I click in here, and we're going to say up to approximately 200 volts is where we're going to set it up to. Now remember, single wire coming from our scope here goes into two wires. So I need to earth one side and probe the second side. So I know that brown is an earth, so I can go in there and I'm going to probe the back end of the primary winding coming from the coil. So if we take a look at the screen here now, we should be able to see the primary winding. I'm just going to freeze that and go back through the frames. There we go. And I'm going to drag this down so we get a view of it here. So if I can pull over here and go to the zero line and pull the zero line down so we get a full look at what's going on. And then remember, I can use the buttons up here to zoom in on one particular part of this display. So I'm going to click on that, and what I'm going to do is go from here. Just pull that box out of the way, give you a good look at it. Okay, now what we can see is our 12 volts, or 14 volts if we're running, comes in. The module earths the coil, so we get a voltage drop. Along here, there is current flowing through the primary winding, and then suddenly the module open circuits the primary winding. So we get this back spike into the primary winding, and it goes up. We can see it's above 200 volts here we're getting. The distance between where it spikes up and where we see this happening here is our spark duration, and then it oscillates out. So let's see, remember we can pull across these markers and see how long the primary winding was actually had current flowing through it. Let me get right to here. So if we look at the box at the top here, the difference between the two lines is shown as a delta here. So we had current flowing through the primary winding for 3.05 milliseconds. And if we want to see then how long the spark duration was, we can drag the other line over. Just to about there. And we can see our spark was a really, really short time. I think on this we can actually see the spark happening if we zoom right in on it. Hold on. What we'll have to do is, don't forget, reconnect our secondary. There we go, the last one there is sparking. You'll see one of the next one as well. That was probably a little bit too large in that one. Let's go down a little bit. That's it. Well, we could definitely see it on the last one there. So, what's happening at this stage is we self-induce into the primary winding a large voltage here, slightly above 200 volts, and at the same time mutually induce into the secondary winding. The secondary winding, remember, comes from here, from the coil, up this winding, into the center segment of the cap, gets put down onto the rotor arm, and the rotor arm then distributes it around to each of the leads here. But the mutually induced voltage into that is going to be approximately 100 times more than what we see in the primary. So if I'm getting 200 volts in the primary winding as an induced voltage, I'm going to end up with approximately 20,000 volts in our secondary winding. And that's basically what the coil does. The secondary system, you can see, just distributes the spark, right? So our distributor here has two functions, really. One, it's sending a signal, letting me know as the next cylinder or the next lug on the reluctor ring comes around, sends a signal to the ignition control module. From the ignition control module then, it's controlling the primary winding switching it on and off, which mutually induces into our secondary of 100 times more value. So if this is 200 volts induced into this, the mutual induction into this would be 20,000, and off it heads out to the top of the coil, into the center segment of the cap, through the rotor arm, and the rotor arm is being turned by the distributor shaft, and now it distributes it out to where my leads are to each individual plug. So there we have basic ignition electronically controlled, as opposed to our Kettering system, which is an actual manual control of the primary circuit. In our next video, we're going to hopefully take a look at our Hall system, and we'll see the only thing that's really going to change is what's happening in here, in our primary system, right? Not our secondary. Our secondary will remain the same. It will still have coil secondary winding, coil lead going over to the center segment of the distributor cap, rotor arm, and then the individual coil leads in the cap going out to the plugs. But the only thing that really changes is how we do this signal part in here. With this system, we're sending an AC wave in here into our ignition control module. So remember, our AC wave is like this. Off we went, and it continues on and on and on as each reluctor passes by and disrupts the magnetic field. When we change to the Hall system, we're going to get a different type of waveform, because now we're going to produce a digital type waveform. And a digital type waveform is either on or it's off. So we do away with this part here. Okay, so we'll take a look at that in our next video.